Hello, and welcome to today's Skill Up session from the DevOps Institute and PeopleCert, powered by Techstrong. I'm your host, Daniel Scheifler, Principal Consultant with Improving, and today we're talking about the fundamental principles of chaos engineering explained. And on our panel today, we have myself and Mark Hornbeek. Welcome. Now, before we get started, I do want to let the audience know that this program is both live and being recorded so that you can view it again later on demand. Also, for those who are available, there is a chat and a QA box over to that right side of your screen so you can communicate in general with the audience and send any questions you have to myself and to Mark. Now, Mark, if you'd be so kind, let's start with some introductions. Tell us a little bit about yourself.
Okay. Hi, Daniel. Thank you for having me on this. I'm kind of an old guy. I've been around in this IT world for, I guess, 48 years. So that's saying something. And for some reason, I'm pretty accident prone. So what I've learned over my life is this idea of chaos is a very real thing, and having to, deal with it is a very real thing. So I started my career in the telecommunications, networking world, and more recently I've been involved as a consultant with large enterprises and institutions. And certainly chaos engineering is one of those, disciplines, if you like, that is getting to be, it always was very important, but as systems get more and more complex, I found that, having a disciplined approach to chaos is critical. So I'm happy to share my experiences and have fun with this today.
So you kind of mentioned that you said you were kind of accident prone, but obviously you're trying to separate. That's not intentional chaos engineering. You mentioned that you want more of a disciplined approach to it. Could you say a little more? What for you then is very specifically this concept of chaos engineering?
Well, the so-called standard definition that you hear about, it talks about testing as kind of a disciplined experimentation on systems in order to, see how they respond to different scenarios, failure scenarios, high traffic conditions, and things like that. And in particular, how production systems respond. And systems are getting more complex, so it's hard to anticipate all the ways that they'll react to chaotic situations, whether the chaos is valid traffic or invalid activity going on in one form or another. But I personally find that not a very satisfying definition. To me, the whole point is to engineer solutions to improve the resilience of complex systems for failure modes that are determined by chaos experiments. So to me, that's a better definition, but I don't see people referring to it that way. So I'd like to emphasize the solution part of the idea rather than the experiment part, even though, the experiments are part of the way you get there.
Okay, so for you, very specific, chaos engineering is not just I'm going to hit it with a hammer and see if it breaks. It's okay, so I hit it with the hammer. It broke very specifically on this fracture plane. Let me patch that over so that the next time I hit it with the hammer, it's less likely to break.
Yeah, that's the idea. And knowing where you have sensitive spots in the systems that need to be shored up or mitigated.
So what does it look like for then to say a maturing kind of a chaos engineering practice to be able to both determine which ways I need to hit it with the hammer, as well as to identify meaningful ways to build in that more stronger reliability into our systems? What have you seen kind of that taking shape as? Is there like an entire department for this? Is it someone's job?
Well, the word maturity has a lot of context.
That's true.
You definitely don't start off by the big bang kind of experiment where you take down half of production and see what happens. You want to build up confidence over time in your ability to, have your systems withstand stronger and stronger kinds of hits and recovery. So, maturity, you start off with fairly gentle,
love taps
types of failures, and then over time build up, more sophisticated and more, serious type of failure modes that you can mitigate and gain the confidence. And don't start by doing that, in production.
Right.
Start by running these experiments in non-production, and then as you gain more confidence, then you can, start running some of these experiments in production to make sure that you're mitigating strategies are working not only in test environments but in production environments, and be prepared to back up if you need to recover.
So out of that, I heard a couple of big things. One, which was expect a time to start small and don't regret the day of small beginnings. You're going to build up to this, but especially to simulate it in a production-like environment that is not production, which to me sounds a whole lot like the same stuff we've been talking about to do effective software testing, right? So is this chaos engineering supposed to be then like security, which needs to be baked into development and design, or is it more of a operations concern where I need to talk about scaling?
Okay. So there is a valid question there, and a couple of questions you really raised. One is the design aspects of chaos, right? Just because we have this thing called chaos engineering doesn't substitute for the idea of you should be designing for resiliency in the first place, right?
Okay.
So during the design process, you should try to anticipate chaotic situations that could happen to your product in production, and anticipate and having anticipated, you should do something about it before you even bother to do a chaos experiment, right? It's
okay.
And then when you get into testing, you're right, there are certain kinds of tests that maybe you know what's traditionally called negative testing, where you're going to inject some failure modes during, let's say, system testing to see what happens. And that's kind of, along the lines of chaos engineering, but chaos engineering is more particular about, injecting chaos into systems, if you like, where you're not really entirely sure what's going to happen because of the complexities of, the combination of things in a complex distributed system. And it's those things that you want to, that I'd say is the valid use case for chaos engineering. Definitely, you shouldn't, say, okay, because of chaos engineering, we're no longer going to do design for failure or negative testing. That's still
that sounds bad.
Important thing to do, right?
Okay.
Chaos engineering is more specific to, how do you build hypotheses for different chaotic situations that could occur in production, simulate those as much as you can prior to production, build mitigations for those things prior to production, and then test them in production as well, so that when the time comes that the scenario actually happens, that you're confident that the system's not going to come down, or at least it's not going to affect a large portion of the system and don't have a domino effect or some terrible thing.
Okay. So check me on this. It sounds, the more you talk about this chaos engineering, that it's starting to sound a lot like it has associations with the core concepts behind agility. The admission of, we don't know everything that could happen. We don't even know all that this feature could work. So we're going to take a small experiment and test it and essentially measure. And it sounds like the concept of those chaos experiments, of specifically yoinking the network router, for example, to see what happens inside of a test system, has some similarities to the development of a new feature. Does that kind of match your thinking?
Again, yeah. So, design for failure is still an important thing. And, but, trying to think bigger about what the kinds of failures might be and then try them out. Right. So, I mean, I was watching an old DVD the other day
okay,
that reminded me of this concept. It was about the Voyager space missions, and how the NASA engineers, they knew that once they'd launched these missions into, deep space, they wouldn't have a lot of opportunity to try and fix things, right? So they had to try to anticipate all the what if scenarios before they launched, because it was too late to design it in later, right?
Right, because you can't send up, here's that missing widget you had.
Right. So, maybe you can think of that as, it's not exactly an agile situation. It's more like a waterfall situation, but still, right. I mean, the idea of anticipating the what if scenarios as you design and as you test, and then for the more complex situations, actually try it in a the complex situations in a production environment, a pre-production environment, and then ultimately you want to make sure it works in production. But in some cases, if you haven't already figured it out before you launch, it's too late.
Yeah, non-recoverable at that point, I can see. Oh, yeah. It looks like we have a question here from the group. One Andy G is asking, so is chaos engineering really just a more deeper form of negative testing?
Yeah, I was saying that earlier, that negative testing tends to be negative testing tends to be very focused on some known situation and very deep dive kind of situation. So chaos engineering is more about the broader types of failure modes that are hard to anticipate. A negative test assumes that you already know what might fail typically, and you're testing for that, right, as a test.
So chaos engineering deals with the unknown unknowns.
Basically, yeah, that's the right domain for it anyway.
Okay.
Nobody says that it doesn't replace the need for negative testing for sure. Negative testing is still a valuable thing. You want to anticipate as much as you can as before you launch into production.
Okay. So kind of building on this, I got two kind of more business oriented questions. We've talked a lot about the tech, from the testing, making certain that the solution is high quality, these kind of things. But every time you mention that, it sounds like we're also dealing with a certain scale, right? Like, hey, at some point, chaos engineering becomes important because your app has grown to 10,000 users or something like that. For example, do I need to care about chaos engineering, say, version 1 just after the MVP? Or what point do I need to start really thinking about chaos engineering?
Yeah, that's a good question. I mean, there's no hard answer for that, in the sense that, there's no like some metric or something, but fundamentally it applies best when you've got a fair amount of complexity, a network or where it's hard to anticipate all the different possible failure modes. That's where it applies.
So about the time that system no longer fits inside my head.
Yeah, and that can occur from multiple types of topologies, right? You could have a network that has many different failure modes that are hard to anticipate. You could have just many different use cases. If you've got a system that has many different use cases, even if it's not a networked or distributed product.
Sure.
So it may be impossible to determine every possible use case. It could be where the deployment environment is uncertain. And that's kind of like the what if scenario, launching Voyager into space. Where you may be able to anticipate many of the failure modes if everything else was, known. But essentially, it's when you have a lot of unknowns that you want to experiment with. That's when it applies. So, how do you judge how many? I don't know. You're going to have to, there's a judgment call there. But I would say that for the most part, modern systems have a lot of potential unknowns in production. So thinking about chaos experiments is, generally speaking, applicable in most modern systems, I think, whether it's a database or, an application on, or a large system.
Okay. So it's a use your best judgment, but expect it to come sooner rather than later. Is that a fair way to summarize?
Yeah. Yes.
Okay.
Yeah, I mean, you probably aren't going to embark on a whole lot of chaos engineering work until you've at least got the fundamental ability to deliver reliably and recover reliably. So, that once you have that, in the DevOps terminology, at least basic continuous flow and basic continuous feedback, you're probably not going to do a whole lot of chaos engineering. But once you get to that basic level, then it starts to become relevant.
Okay. So one of the other pieces you've mentioned a lot with this has been the need to design for failure. Thinking about this from like a trying to do this the most effective way possible. Wouldn't it be cheaper just to design for failure in the first place and not have to spin up a whole discipline and teach my teams and risk my systems coming down while I, hit it with the hammer?
It can be, but if you're wanting to validate that design, then you're going to need to set up some tests and some experiments. And the question is, do you have within your, your design environment, development environment, test environment, the ability to do that? So in some cases, you may actually have to build some simulation in order to perform those experiments to validate that design. So I think there's a question here as, to what extent can simulations support the need of, chaos engineering experiments, and I think there's a very strong role to play there. I can tell you, I was once the general manager overseeing a new product. It was a pretty sophisticated product for measurement. It's called optical metrology system. It was a system with cameras and lasers and precision motion and all that to measure very precise parts.
Okay.
But we were wanting to introduce a new, product to the industry, and that's an industry that doesn't change very much. And we knew we didn't have a lot of time because the trade show that we were going to introduce it in was, only 10 months later. And there are literally 17 different engineering disciplines involved to create such a machine. We knew we had no way of, after the fact testing and improving. We had to basically design it pretty much right the first time. So we invested quite a lot in simulation, and a lot of those simulations had to do with failure modes in a number of different dimensions, not only the software operation, but things like ergonomics and things like repair capabilities, and trying to anticipate all those what if scenarios during the design phase, so that when we actually put the thing together, which happened, by the way, at this on the showroom floor for the first time, it worked, and it turned out that our simulation was our marketing. Turned out to be the marketing demo that preceded the actual, physical assembly on the shop floor, on the show floor. But that had a lot to do with basically anticipating failures. The normal case of the design was complex enough, but all the different failure modes, there were so many different scenarios we knew we couldn't possibly, afford to find them during testing. We had to anticipate as much as we could during development, and then at the same time, try them again during testing to validate our mitigations were working.
Okay. So can you tell me a little bit more about what these designs to overcome failure modes would look like? So you mentioned a number of different disciplines, but let's take one I think most of our audience will be familiar with. Let's talk about a network failure. What does the design to handle a network failure in, say, the software components or even in the Azure infrastructure end up looking like?
Okay. Well, in the network world, it usually starts with you've got a stack of protocols basically.
Mm-hmm.
So the protocols themselves have to be designed for resiliency, right? A lot of if you dissect most communication protocols, you find out a lot of the design has to do with anticipating various kinds of failures in the actual protocol design.
Okay, fair.
Things like restarts when you have a failed packet or something.
Yep.
Detecting when you've got latency problems. There's many different kinds of problems in networks, and they
error
can
correcting codes and the kind of thing.
Exactly. Yeah. So there's going to be many failures occurring at each layer because these are multi-layered systems.
Right.
Often you've got, like, if you think about the so-called OSI stack, there can be many layers. If you take even your cell phone, right, there's so many protocols going on in there. It's amazing. So all at the network layer, that's the first level, right? The interface itself. But then beyond that, it's, the system and how, system resources. If you can have a perfectly valid protocol operations, but if it runs out of memory, that wasn't part of the protocol. Yeah. So the system level types of failures, and you want to have metrics and observability going on in the background, and automation of recovery of that. Maybe restart a queue or restart, even the system at some point to keep operations going.
Okay.
So
So you mentioned a key word there that I want to kind of zoom in on and call out. It sounds like in order to be able to do chaos engineering well, to really benefit from these experiments, whatever system I'm designing, I have to be able to observe its inner workings. So I understand what happened when I yoinked the plug over here. Is that about right?
Yeah.
Okay.
Yeah. So certainly observability is a key, part of the chaos engineering discipline. If you can't observe what's happening, it's pretty hard to detect a problem early enough to do something about it.
Yep. It's hard to tell that my system failed if I can't see it.
Yeah. So observability is a fundamental requirement to do chaos engineering properly.
Okay. So let's then kind of camp on that a little bit. In your experience, what have the most successful implementations of chaos engineering at any level of maturity really have had in common? It sounds like all of them had to have some layer of observability built in.
Mm-hmm. Yeah, for sure. I mean, there's a lot of, I guess, table stakes for chaos engineering.
Tell me more.
So observability is one of them.
Mm-hmm.
The ability to, inject faults, right? So that may require a special tool. Otherwise, you can't run the experiment. Let's say you want to experiment to see how a system responds to slow communication. So you want to be able to inject delays. Would be an example of a chaos fault injection, right? Or maybe you want to take down a component in a system, so you need to be able to switch that component in or out. So there's a lot of fault injection capabilities that need to go hand in hand with chaos engineering, and you need an experiment, so you need to be versed in how to set up experiments. What's your hypothesis? You don't just go off and run random experiments. You're trying to test against a specific hypothesis, so you want to have a scientific mindset when you're doing chaos engineering. So that's a requirement. You want to be versed in automation, right? So you don't want to do all of this manually, although you can run manual experiments, but for the most part, you're trying to respond to things that are happening in complex systems in real time. So you better be well versed in automation and how to orchestrate and automate, orchestrate systems and automate tasks. So that's kind of table stakes for before you can really do a lot with chaos engineering. You need to understand what does good look like, right? I mean, what is the can you distinguish between expected normal behavior versus a failed mode of behavior? So that's more than just observability. That's understanding what you're observing. So understanding what is your normal state is another requirement. You need to understand your system architecture well enough to know how one type of failure could impact the rest of it. So this idea of minimizing blast radius is something that is associated with chaos engineering, where you don't want to have one failure domino to the rest of the system. You want to contain the failure to some local area and let the rest of the system carry on. So again, understanding that idea, understanding ways to contain failures is important. So there's a lot of principles associated with chaos engineering that it's not just a matter of running some tests. All of these concepts are part of chaos engineering.
So can you back up a step for me? I want to camp on one in particular that you mentioned, which was the need to understand what good looks like. What does that process of building an understanding of what good looks like look for a company who's, say, just trying to get started in this? I've already got basic CI flow. I've got some basic observability. I can tell when stuff is flowing through my environment. What do I use to even talk about what is good in terms of my system design?
Yeah. So it's a good question. I would refer you to the concepts that are pretty well defined under site reliability engineering. This idea of having service level objectives. So the idea of a service level objective is you're pretty clear about, from a user's point of view, what good looks like, right, in terms of objective measures. So if you don't have SLOs in place, it can be hard to determine what good looks like, at least in any measurable way, right? So put in place those objectives and then the indicators to go with it. So that would be part of your observability and understanding your steady state, if you want to drill down a little deeper on that question, right? So, for example, let's say it's a bank account, right?
Right.
From a user's point of view, you want your system so that you can log into your bank account from your phone to be reliable. Okay, what does reliability mean? Well, if it works 9 times out of 10, is that good enough? Probably. If I have to do it again after 10 times, maybe it's okay. So maybe 90% of an SLO, 90% of the time, that would be good enough. But once I get into my bank account, I want to make sure that the bank balance is accurate, and that had better be more like 99.9%. Right. So
the 3 nines rather than the 2 nines.
Exactly. So,
Okay.
you need to understand your user use cases. So at least from that point of view, that's what good looks like, to understand your user journeys through your system.
Mm-hmm.
And you can, like I say, assign SLOs to that. That's what you really should be doing if you follow the SRE disciplines, and then put in measures, service level indicators to help validate it. And then, what to do if it fails. Well, that's your error budgets and your error budget policies. But fundamentally, that's one way to say what good looks like. There can also be, things that are not SLOs, that are not really user-oriented measures of goodness, that can be system-oriented measures of goodness, right? Does the system have the capacity to, not just to handle one user, but to satisfy your business goals. So, so it's a very good question. What does normal look like? What does good look like? It's very worthy thought. All right, it takes a lot of time. I once had a client that I was talking to them about SRE practices and SLOs, and they said, "Oh yeah, we're going to do our measures on Friday afternoon." And I almost fell off my chair. I said, no, you don't just sit down on a Friday and design your SLOs. This is a process. It takes quite a long time to really think this through and try to understand what does the good look like. And, it's a disciplined approach to even just figure out what good looks like. In other words, it's experimentation. Again, it's kind of a form of hypothesis testing to see what good looks like. Was good enough? In other words, it's not just what good looks like. We could all say, well, good is when everything is perfect. Well, that's bullshit, right? Nothing is ever perfect. It's not reality. So what does good look like? Well, it's something less than perfect. So we need to be able to define what it is. And that's the process of defining SLOs and SLIs to measure goodness. Mm-hmm.
Okay. Now,
I hope that answers your question.
It does, actually. That's fantastic. Basically, I hear, hey, start with an objective. What does it look like from customer first, and then bring that down to actual measurables for the performance of your software or of your network. One thing that leaves me wondering is that it sounds like that's a pretty high level conversation, like me and an executive at the higher level, or maybe like, the manager of an application development department, to really establish the core SLOs for the product that sustains the company. How could your average developer help with that? What can they start developing now, so that by the time they get to that point in their career, they have some of the basic tools they need to have that conversation?
Yeah. So, I mean, what good looks like should be of a concern to everybody in the organization.
Yes, I completely agree.
Yeah, I mean, what can you do about it may vary depending on what your level is, right? I mean, certainly at the individual engineer level, let's say, developing code, then understanding good coding practices for reliability and security is something that you can do to build up confidence and capabilities as an individual. So certainly studying all the different dimensions of chaos engineering would be a good thing to do, but in general, just understanding and design for reliability practices, design for security practices, coding practices would be a good thing at an individual level.
Okay, and so then I heard. Go ahead.
Yeah, and then put in place again observability and monitoring for those things that you're responsible for, at least, right? Maybe you're not responsible for the entire system, but you can certainly make sure that you've got a clear understanding of what your service level objectives are, if you like, and how do you get indicators for those things for whatever your domain of responsibility is, and that would put you in a pretty good state for the growth, and as you build up responsibility to a wider and wider area of the the whole service or product.
Okay. And so it sounds like this chaos engineering approach, you really can actually start back towards the MVP by starting a discussion on these service level objectives. Hey, if I build this, what's necessary for people to keep coming and buying the service that this software provides? And be able to have that conversation, so that the moment I've released it and I have proof for my experiment that, yes, in fact, people will pay for this, now I can go and immediately start saying, okay, what's necessary to keep it in a state where they will want to use it? This conversation about how to keep the network or the software running even when something falls over, but that I can take it in kind of this iterative approach to learn to practice the experiment mindset, that hypothesis testing, that I can start rolling out SRE best practices as I go, that I don't have to get it all right at the first. And it all hinges on, are the people in the work taking the time to learn to do it better? And are the people at the top talking about what really matters. Is that
right? So yeah. Sorry, did I interrupt your question?
No, continue. I was trying to lay up. That sounds about right. What color would you add to that?
Well, only that, you're touching on the fact that in order to do chaos engineering properly, it's not, there's a lot of individuals can do, but to really have the big bang effect, it takes a cultural approach or whole organization approach. If you really want to have a resilient system that can, respond automatically, if you like, as much as possible to turbulent conditions, if you like. So that is probably the number one challenge, frankly, with a lot of these frameworks, including chaos engineering discipline, is getting the organization to buy in and to actually give it priority attention, right? So that's true at the business leader level, whether you're a developer or QA engineer or SRE or ops person and tools guy. All of this has to fall within some level of priority, and how the organization values this type of work is really critical. At any point in time, values are whatever they are, and it takes a lot of effort in leadership, in fact, to evolve values of an organization. So if it's not valued at that senior level, then individuals probably won't give it the attention that it needs in order to do a good job of chaos engineering.
Okay.
Maybe I got off on a tangent there. I'm not sure.
No, I think that's a really deep and critical point that I'd like to ask actually to double down on a little bit. You mentioned that there is a finite limit to what the individual can influence in their system. And that at a certain point, it does have to become something that the company either does or does not value, because it has to get some focus.
Right.
What are some
funding
ways
and priority?
Right.
Yeah. Funding, right, and the recognition and all of those things.
Yeah.
Become critical.
So building on that, how might you suggest someone who's interested in introducing this to their company get started? What kind of, not necessarily arguments, but observations, value statements have you seen be effective in not merely catching the attention of the executives, but helping to frame chaos engineering in a light that says this will add value if we do it?
Yeah, unfortunately, a lot of the ways to do it are kind of the negative scenarios.
Wait till something bad happens?
You show them what can happen if you don't do this type of thing. And if you show the right person the right case, then they get more excited. I'm thinking about a case that I was involved in not too long ago it was actually a DevOps transformation effort.
Yeah.
We were going through an assessment, and as part of the assessment, there was the CTO of a very large, I won't name the name of the company, but it was probably the world's largest gift card company. And they have a lot of, technology behind the scenes that orchestrate, the gift card transactions, right? And partway through the assessment, we realized that, they hadn't put in place a lot of mitigations for some of their failure scenarios, and we literally stopped the whole assessment and said, we're going to focus on this instead. So it really boiled down to getting the right person, some visibility around what potential failure modes are there, and then all of a sudden you start getting people interested to take action when they see, oh my goodness, this could really kill us.
So essentially, it's an act of translation. The right guy had to read the stuff and then say it in another language for the CTO to realize, oh, that's bad.
All right. Yeah. I mean, the one I use with financial companies, which is a very real one, you may have heard it's a famous case. It's often referred to as Nightmare on Wall Street. The case of Knight Capital in the 2014 zone, where they had a bad deployment, and they were the darlings of the electronic trading world. They had the software that does electronic trades. Like the company's called Knight Capital with a K, right? Knight.
Yep.
Like the Shining Knight Capital. And anyway, they had one bad deployment, and all of a sudden, in real live trading days on NASDAQ and the New York Stock Exchange, they started accepting bad trades. And within 43 minutes of trading on, live trading, they lost $365 million. And the company went bankrupt before the eyes of everybody.
Yeah.
Right? So for fintech companies and banks and that don't like to hear that story. And, it would have been better to simulate some of those failure modes ahead of time before you do it in a live environment. That's one way to get attention. Usually when I tell that story, most of the fintech folks start paying attention, but it's a real story. You can there's even books on the case of Nightmare on Wall Street, or lots of free articles if you go searching for it. But
I'll definitely go look
things
for
like that, right? Identifying, clear failure cases that if you haven't considered them, then you do want to consider them, right?
Okay.
All of a sudden you get priority. And there's some new, I've seen in the news lately, more articles about something that is, human failure case that we should be more concerned about, that doesn't hit the news that much typically, is these solar flare attacks. All right. It's possible that we could have a solar attack that could literally take out all the electronics and power grids on the planet. And that would be not good for humankind. Yeah. And yet we're not really spotlighting that so much, pardon the pun. But that's an example where, the more you spotlight it, the more you're going to get funding and attention to the problem. It is a real problem, just like climate change is a real problem and so on. Yeah.
So there's a question we just got in from the chat from one Andy G again. Thank you, Andy. So he mentions that we've been talking about this observability and SLOs and what is in his mind systems thinking. But what about coverage, right? Does a good chaos engineering have adequate coverage for all of the components of the system? Like, where's the balance on that?
Well, just like, security, quality, reliability, there's no such thing as 100% coverage. You're going to have to make a judgment call. So the most important thing, I think, is to have a coverage criteria and at least have some rules, goals around that criteria. You're not going to accomplish 100% because there is no such thing as 100%. So it's sort of like an SLO itself, right? You're going to have to decide what amount of risk are you willing to take, and make sure that that's agreed by the organization, and build your coverage criteria around that. So in the case of chaos, it really is trying to identify as many possible risks as you can and decide which of those risks are you going to try to cover. So it requires some deep thinking, and in some cases your experimentations are going to identify additional things to put in your, if you like, risk backlog. And you want to decide what level of that, you're going to have severities and priorities assigned with different risks, and you're going to need to have some policies around that. Okay, of at least the known, security, known risks. What is your coverage criteria? How many of those are going to get covered? How long are they? Are they allowed to stand before you deal with them? Things like that. So you want to have a policy. There's no one standard policy, but you're going to need to determine the policy for each individual service or product.
So when you say determine policy, is that going to be like a decision of the team that supports that microservice, or is that needed to be bubbled up, say, to the chief security officer or the chief technology officer who has to make that decision?
Yeah, it should be at the strategic level. What is your policy? For the policy might be, out of all of our known risks, you can have a graded policy, right? So severity 1, priority 1 risks will not make a deployment until we identify a mitigation plan for, an observability and a mitigation plan for those risks. That would be an example of a policy. For the lower severity priority ones, maybe we'll allow them to, we'll continue releases even though we know that they're possible risks, but they need to be cleaned up within, 6 months or something like that. So these are examples of just policies. You can have your own policies. Different services and products may have overall, different levels of risk for a business. So even if they fail, maybe it's a tier 1, or tier 2 service. It may have a looser policy than a tier 1 service. So these are all things you need to grade and have policies around. And that should be done even at the strategic level, executive level. Usually there's a governance strategy, governance or risk officer this would boil up to. And then people working on individual services and products should have, clear understanding of what the policies are and how to comply to them.
Okay. So it sounds like that these policy decisions need to be made reasonably high up the organization to balance the strategic needs of the technology and our system to keep it running with the economic needs of the business, because every extra of those nines in an SLO costs more and more. So how does that information then need to kind of trickle down?
If you think about chaos engineering, you've got tooling, you've got resource investments, and all of that requires investment and therefore requires executive input.
So how does that information then trickle down to the team on the ground, as it were, doing that work? Like Agile always has this product owner. Does the product owner need to have these conversations? Does the in-team architect, who's the right person to start asking these questions up the chain so that the team can make appropriate adjustments to how they build, so that they can design for failure, for example?
Right. So there is, again, no standard, but what I have found to be the best practices, there's usually some kind of executive responsible for governance, and they'll be the ones that are responsible for the policies. Anybody in the organization can contribute to those things, right? Anybody in the organization could contribute ideas to the policy, but there should be some standard, some visible document that describes what those policies are. Yeah.
Okay, so the first piece is, of course, get something in place, start having the conversations, and then people can start acting. The second piece you mentioned that we want to talk about is being able to diagnose severities and expectations, right? Like tier 1, tier 2 applications. That can be relatively easy. How critical is this to run the business? How do I diagnose severities of failure? Do you tend to use a dollar and cents estimation of the cost of the impact, or do you use some other metric?
Depends on the mission of the business, right? If it's a military organization, it's very different than if it's a bank, right? The cost of failures are measured differently. So, it really depends on the mission of the organization. It boils down to mission. So understanding what the values are of your mission and, where you can have, what types of risks are going to most impact your mission, whether that mission is making money as a financial institution or serving a network service, if you're let's say a service provider, or protecting something if you're a institution that's responsible for doing that. So it depends on what the mission is, and you want to grade, have policies that are grading the different failure modes according to what's important to your mission.
I think that makes sense. Okay, so you've sold me. Let's say I am down for this. I want to get started with this chaos engineering. What should I watch out for while I start trying to implement this? Do you have some good strategies to kind of recommend to help us kind of dodge some of the potholes that are coming?
Well, there are a lot of challenges and strategies. Probably the number one challenge, as I kind of mentioned before, is culture. It's trying to overcome the apprehension, about focusing on failures. People like to focus on the positives, but it's actually kind of fun to focus on failure modes, actually, when you get into it.
I can buy it.
People don't like. Well, a lot of organizations have a culture where they, if you go back to the so-called Western model, right? The one end of the culture spectrum is pathological, where failures are not recognized or covered up, and people don't talk about failures. So that's the bad side. The other end would be what they call the generative culture, where failures are taken as a opportunity to learn. So that's the good type of culture. So, but understanding what is your culture is the first step, right? What end of those spectrum are you, right? And depending on where you are, the strategies for overcoming those issues are going to be different. In all cases, though, whenever you're dealing with cultural issues, again, the real solution is going to end up with leadership, and because culture tends to reflect the values of the leaders. And hopefully those leaders are picked according to the values of the, of their mission, whatever the mission of the organization is. So education can play a role, but training and education in and of itself does not change culture, but it can support a cultural change. But definitely having, stated cultural objectives and rewarding examples of moving in the direction of the culture you're looking for are good things to do. But culture is definitely one of the largest concerns that I see with this. In general, the next would probably be making sure that, like we talked about before, that observability is in place, right? And understanding that you do have an ability to see what's going on with your systems with respect to those high risk use cases, and make sure that that those failure modes can be determined, right? Understanding what is normal, so dissecting your systems from a user's point of view, so that when you get that observability data, you know whether that's good or bad behavior of your systems. So investing in monitoring, observability, understanding, how to put in place the right kinds of metrics and logs and tracing, so that you can get the proper observability. Understanding your system itself, right? What are the boundaries? How does the system operate? Where are the weak points? Where are the choke points? Where are the single points of failure? Things like that. So mapping out system dependencies would be part of the solution.
So both of those seem to play on like that awareness aspect, right? So like awareness of what's the mission, make certain that we can actually try and have some of those conversations, and awareness where our culture is today. Awareness via how's the system normally operate, and even the awareness of by our design, where's the most likely point for a failure to knock us out. Like being able to build that seems to be a great place to start, no matter what level you're in.
Yes. Yeah, there's a fairly significant list. And nobody said that chaos engineering is easy.
That's very true.
Having the right tools in place, or knowing where you need to go get tools, or build your own tools, but tooling and automation capabilities. If you haven't got that already, then that's a challenge. But that can be, the technical aspects of that are relatively easy to overcome through training or hiring practices.
So would there be some resources I could go reference to start getting my hands around this culture piece? Because like the observability, I could go find some stuff for that. We can go look at SRE practices, for example. But how do I approach this cultural challenge, especially if, for example, I'm not titled and in charge?
Yeah, it's a tough one. I can tell you, our own DevOps Institute, part of PeopleCert, most of their foundational level courses have at least modules talking about how to support what good culture looks like and how to address it. But generally speaking, big bang culture changes, if necessary, are going to come from leadership. But everybody in the organization can have an influence on culture in the way you behave. So if you behave in a way that's empathetic to your colleagues and doing active listening, demonstrating learning from failure, that can be contagious. And even at the lowest levels of the organization, if you like, it can have an influence.
Okay, so lead yourself first, in other words.
Yeah, lead with your own best practices of culture as an individual, even if the organization itself has some problems. But
definitely,
ultimately, it does require leadership to emphasize the right kind of culture.
Okay. So I've got a question coming in here from the audience, kind of in this same zone of as I'm trying to develop the chaos engineering practice. Abdulkabir asks, and I apologize, by the way, if I butchered that name, but he asks, what are the key performance indicators, the KPIs in chaos engineering? What should I be looking at?
Right. So again, I'd go right back to the SLO thing. If you don't have SLOs in place already, that would be a good place to start, right? Knowing what are the service, what does good look like, right? So in chaos engineering, you want to make sure that you're able to sustain your service level objectives in the face of chaos. So that, to me, is the most important thing. That has a value with or without chaos engineering, but certainly it has value for chaos engineering. If you can put in place SLOs and have metrics and dashboards associated with the different aspects of your service level objectives, that's a great place to start, in my opinion. You're not just looking at things like, failures per minute or something like that. You're trying to understand, what is the impact on the user? And then the next tier would be, what's the impact on your mission, right? Whether it's a business mission or some other kind of mission, depending on the type of organization you're in. So that can transcend beyond the user's experience. You want to have metrics for your business. What's the impact on that? And ultimately, it boils down to focusing on those areas that are going to have the highest risk for your mission. That's how I look at it anyways.
Very nice. And so you'd be looking to measure the SLOs that will negatively impact mission if they're not kept high.
Yeah.
Is that about right?
If they're not kept within whatever the SLO is, some SLOs don't have to be that high, as long as they're satisfactory.
Sure. Like the 9 times out of 10, I need to be able to log in from my phone.
Right.
Okay. So what other kinds of things can you recommend, say, as I'm starting to mature this and the company's starting to get comfortable with this chaos engineering idea? Do you ever see some kind of complacency setting in, say, oh, well, we've already got the policy, I don't need to go re-review that next year, for example? What should I watch out for as we begin to grow in chaos engineering so that I can keep it sharp and effective, as opposed to just, it's a thing we do?
Yeah, so this world is unfortunately never standing still. You're either, there's an old adage, you're either going ahead or back. There's no standing still, because if you're standing still, then your competitors are probably moving ahead of you. So there is no standing still with, chaos engineering is part of that. As your systems grow in terms of, success, hopefully, then, you're going to be adding new features, new capabilities, new innovations. And every time you do, then there's new possibilities for failure. So it never really stands still, right? You're going to have to continuously innovate to figure out new, different potential failure modes as you introduce new innovations. If you're not introducing new innovations, you're probably going out of business anyway. So, it never really stands still.
So there's that need to kind of adopt a what feels like a Scrum-like cadence to this. Hey, every once in a while you need to go back and either reevaluate or expect something new came on, and then you must make decisions again.
Yeah.
How do we make that more palatable, right? Because nobody says, oh, hey, I got this thing that'll help your business, but it's a subscription model. Nobody likes having another new bill to pay. How do we frame that in such a way that it feels more like that, hey, I'm constantly innovating, rather than, oh gosh, here I have to do my security reviews again?
Right. So organizationally, who owns chaos engineering? Who owns it from the point of view of establishing the practice and maintaining it, if you like, and growing it, for that matter, right? So that can vary, but for most organizations I've worked with, it tends to be, a focus the focus is owned by the SREs and the ops teams, because they're the ones that are going to have to deal with chaos in production ultimately. But but they don't own it alone, right? I mean, development and product owners have a large role to play. So there's a lot of collaboration, but somebody has to, be on first, if you like, to really drive home the need to keep it as a focus. So that can vary depending on the organization, but who owns chaos engineering, it ultimately boils down to that. Who owns not only the implementation of it in the first place, but the sustaining of it in the long run, because it never really goes away. You're always going to have the concern about, reliability in the face of success as you innovate and grow and change things. So, it boils down to, there's an ongoing future for chaos engineering.
So you got to decide who's on first.
And you're done. Yeah.
And then from there, actually emphasize it's not a project. We're not going to do this and then be done. It's going to be a change that becomes part of just how we do business. And it needs to be on that cycle, just like budgets are.
Yeah. I mean, if you think about it in terms of the 3 ways of DevOps, right? It's once you get to task, flow, and feedback, you then get into what's called continuous experimentation and learning. That's a sign of a more mature organization, where you're deliberately and proactively looking at expanding, your learning through experiments. And chaos engineering, in my mind, is part of that.
Definitely,
It's not
especially
all
with the
of
way
it.
you've emphasized the hypothesis testing.
Yes. Yeah.
Okay. So we've expanded on this concept of what is chaos engineering fundamentally, what are the key challenges in going from nothing to something in it, especially around the company culture change. Where do you see the discipline of chaos engineering kind of trending off into the future, say from our vantage here in 2023?
Yeah. So first of all, at least again, I can only speak to the organization that I deal with or hear about. But I see chaos engineering becoming more mainstream. It's not just the Netflix of the worlds that are doing it.
Yes.
So in many of the SRE and DevOps transformations, I see it becoming more of an item that we're transforming to. I'm actually going through a pretty large transformation at the moment with a large fintech client, and it's one of the enablers that is in our next phase of of a 3-year plan, right? And the idea of integrating tooling for chaos rather than just some of the other types of tooling. So explicitly having tools. There are commercial tools like the Gremlin tool set and the Gas Monkey tools from Netflix and so on.
Yes, the
But
Simian
in
Army.
general, exactly. Yeah. So building up tool capabilities for more and more different kinds of chaos scenarios, I think that will become more visible. Certainly with AI and ML, there's a lot of opportunities there to make more sophisticated tools that are more responsive. So in general, automation of chaos, using AI and ML as a way to design experiments and to execute those experiments is interesting. I've had some fun with that recently, and I was surprised, with some of the responses I got from even just ChatGPT or Ask Sage, some of these other tools. And I find that fascinating how these systems already can scan a large body of information and come up with some scenarios that you might not have thought about. So that's one of the arts, if you like, of chaos engineering, is being creative about what possibilities are and then figuring out what to do about them. So that, I think AI and ML can be a good co-pilot in that chaos co-pilot in that sense. In general, standardizing, if you like, I hate to use the word standard because it conjures up certain things, but building common approaches to safety and responses would include not only resiliency from a functional point of view, but also security point of view. This idea of continuous security that is more than just a DevSecOps view of the world, but more of an end-to-end security point of view. And you've got a lot of new cases coming along in the technology, things like edge computing, IoT situations, other forms of reliability. So the database situations. There's many opportunities to apply chaos engineering, even now and well into the future. I don't think it's going to go away anytime soon because the fundamental idea that we can't always anticipate every possibility is true. But again, I would like to remind everybody that that doesn't mean that it substitutes for good design for reliability or negative testing as well. These things are all part of an overall set of strategies that you should be considering in your systems to ensure reliability. So those are some of the ideas anyway.
Yeah.
I would imagine that just like the federal government in the US is pushing for better security software with their acquisition or with their suppliers, I think this idea of chaos engineering is probably going to be coming on the horizon more and more and more as well. Like not only should it be secure, but also reliable as you get more dependencies on these software systems. We've certainly seen many cases where they weren't dependable enough.
Definitely. Well, thank you very much, Mark, for your time today. Thank you to the audience for joining us as we discuss the fundamental principles of chaos engineering, talking about what is it and how it really is more of an approach to business. How you need to keep in mind that the best thing to start with tends to be your SLOs, your service level objectives. How do we make certain that the stuff that the customers came to this software for continue to happen? And then being able to determine among those, what impact to the mission for the company do we need to protect against? What likely risks? And of course, talking about how this is going to need some pretty strong leadership from within to make it a new part of your culture, to make it a new part of just how business is done, because it's not a project that you just do a little while and then stop, because the world continues to change with us. And so we hope that you've gotten to learn a little something from here, from myself and from Mark. Mr. Thank you, sir. Now, I would like to turn your attention to the current handouts, where we have the registration link for next up, the DevOps program on how chaos engineering transforms testing in the DevOps workflows, which will come on Wednesday, October 25th. So I hope you guys will go ahead and check that out. And thank you very much for joining us on this program.